talk about Elm, and I work for a company called Kabisa. And the short version, we care about software. We like to think ourselves as craftsmen, so we like to produce good quality software. And we have, well, this is not seen. We have 2 offices. We're also opening now an office in Eindhoven as well. And we have existed for over a decade now, over 10 years. And yeah, if you have some questions later on, just ask me. So my talk is going to be about Elm. And what is it? Elm is a functional programming language, statically typed, which compiles to JavaScript, HTML, and CSS. And it's meant for building web-based front-end applications. So who is already familiar with Elm? Heard of it? Okay. So how many of you are backend developers? Quite some hands. And how many people are doing front-end? Okay, so I'd say it's about over 40% front-end, 60% back-end, and maybe even managers. I don't know, I haven't asked. So yeah, the language, it's a functional language. It's a similar style to Haskell. It's also written in Haskell. It's strongly typed and started out as a graphics library because the guy who invented it, he wanted to have some element on a page and wanted to have centered, and it was kind of hard to do with pure HTML and with CSS, so eventually he got really eager and he wrote his own library. Later on it developed into a functional reactive programming language, and nowadays he tries to make it a mainstream programming language to do front-end stuff. And the nice thing about it is it guarantees no runtime exceptions. So if you write your program, you can add compile time, you can check if it works or not, instead of having a user do it for you. And it's also because the guy who wrote it wants to go mainstream. It's very reliable, and the compiler errors that it gives you are very friendly and are actually helpful for developers. Yeah. So if you compare to other languages, this is a little bit how I also, by the way, see languages. By a coincidence, somebody else made this. JavaScript is kind of a monster sometimes, because you can do all kinds of stuff. It can result in ugly code. And Haskell is all the way on the other side, which is a very advanced language, but it's also kind of hard to learn. And Elm combines those, well, it doesn't combine JavaScript, but Elm is a language which is a little bit similar to Haskell, but not that advanced, so it's not that's too hard to understand. So the Elm guarantee 0 runtime errors is, well, it's kind of a hard statement. So prepare yourself. Yeah, this is going to be a talk which might blow your mind, hopefully. So one of the things that you'll probably, if you look at the syntax, you find difference, is that it uses spaces. If you're used to Java or whatever, it uses spaces instead of commas to delimit arguments, except for if you have some collections, so list, record, or tuples. And yeah, currying and function composition is something you'll have to get used to if you're not coming from a functional side. Who is, by the way, doing functional programming? Okay, who is familiar with it? Okay, that's good. So it's not too alien for you. So let's dive in. This is a Hello World program. I hope is it readable by in the back as well? I'm standing in your way probably. So in this case, we import a module and we want to use the test function from it. Can I highlight? Yeah. So we want to use the test function from the module HTML. And our module has one function called main, and it outputs some text to the screen. That's basically how it works. Since it's also a type language, you can also use type annotations to specify what the input and the outputs are of your function. So in this case, this list function has only an output, has no input values, and it outputs a list of integers. And in this case, we have a record, so it's kind of an object, similar to an object in JavaScript, in which it has some fields. So in this case, we have an address, which might be string, it might be empty, or an age, which is a number, and a name, which is a string. And this is a way to create a function which outputs this record. And we also have tuples, which are delimited by normal brackets, which is, in this case, composed of a string and a number. So, where's my mouse? Yeah. So, a little exercise. Can anybody spot the error in this code? Or a possible error? I know it's a little bit early in the morning. I got up at 6 o'clock this morning, so for me it's also, I have to get into it. No? Yeah, just shout.
First name.
First name. Yeah. Good one. So I made a typo. In this case I have a record which should contain a first name and a last name, but in here I misspelled it. I forgot the R. And this is the output you get from the compiler. So without even running the code, this is just compiling, trying to turn my Elm code into JavaScript, and it can already spot that I made a typo. And instead of just saying, well, you know, you made an error somewhere on this line, on somewhere in this record, it's actually trying to be specific, and it's going to cut out just that one field from my record and say, this is the one element that you got wrong. And it's even comparing the two side by side, so first name versus fifth name, so you can easily spot what your error is, which in my opinion is very nice. So how does, I already gave it a little bit away. So how does it look like? You define a function, you give it an input. So the first element in the list of a type annotation is the input argument, followed by probably a second argument, and the last one in this list of type annotations is the output that my function is going to return. So that's how you can read it. Yeah, sorry. If you have any questions in between, just ask away. So in this case, if I have a function 3 times, it's going to repeat some string 3 times. And you can see that this function is not complete. So this function repeats, I got only one argument, number 3, but didn't get any strings. So in this case, I'm composing a new function, which when it receives one string, it will repeat it 3 times. So if I feed it the string hi, it should return hi, hi, hi. That's basically it. And one nice thing also about Elm, and you can also, is borrowed from F# and Elixir, is that it has a pipe operator, so I can pass the output of one function call next to the other one, and you can basically compose your function together, which reads nicely. And yeah, these at the bottom are 2 other examples, which I think by now should speak by themselves. This one is also similar to this operator, so the double arrow, but instead of applying this function immediately, it's only going to define a new function. So it's not going to compute the value immediately, but it's only going to define what my function looks like. And in this case, it's using the output of is even to the function not, which will turn a boolean upside down. So like I said, it's strongly typed. Uses type annotation, they're optional. The compiler can infer them for you, so you don't have to think about it. But you can help out the compiler by saying, hey, I want to use these types, and then the compiler can actually correct you in case you don't write your code correctly. It has union types, so you can compose new types by combining other ones. So for example, you could say that, I don't know, your number is either an integer or a float, for example. That would be a union type. So it can be either one of those 2 types. And yeah, the one also nice thing about it is that testing is good. Testing your code is nice, but being able to write impossible code, so the one that is checked by the type compiler, is in my opinion even better. I've spoken to several companies that are using Elm, and they write 0 to no test at all, because they trust the compiler to give them a warning when the code won't work. And usual standards, you'll think, well, this is crazy, because testing should be done in every company. But the compiler, the type system is so strong that people actually rely on it, which in my opinion is also a good thing. So this is an example of new type called action, and it's composed of 3 other types, which is either new, it creates user, or delete user, and the user is actually a string. So when I compose a new function called new user, it will return a user, which in this case is just an empty string. And another one. So the type system in Elm also helps you to write correct code, which won't produce any runtime errors. And in this case, well, what could actually go wrong with this call? Sorry? Empty list, yeah. Because what would happen if our list here, so the function list, I should perhaps explain it. The function head gets the first element from a list. So if our list is empty, getting the first element from the list and doing ×2 could go wrong if our list is empty. So this is actually invalid code in Elm, because Elm will tell us, well, it's not possible to run this function just on a list, because it might be empty, and in those cases the list head uses a maybe type, which is either the value we're gaining back or nothing. So by using the type system, Elm guarantees that you cannot write code which might result in runtime errors. Sorry? Oh. Yeah, so this is an example of a view in which I passed it a model and I returned some HTML. And that's the nice thing about it. There is no try-catch in Elm. Either your function will work or the compiler will tell you it won't work. There's nothing in between. So, I can tell you about it, but that's probably a little bit too theoretical. I would like to try and do some live coding. I've never done it before, so bear with me. It's also a little bit early in the morning. Let's see, we have 15 minutes to go. I probably have 10 minutes left for the last part of my talk. So I only have a short 5 minutes to tell a little bit about it. Let's see how far I got. Yeah. Where's my mouse? So is this a little bit viewable? No. It's a new screen, of course. So in this case, the Elm reactor is a tool from Elm, which will show you the files I have in my directory, and it will also help me build the project and compile it for me and show the output of running my code. So I didn't make any errors, yay. Although some spelling errors, but that's okay. So this is a simple example. This also shows how Elm, or the creators of Elm, actually try to help the developer. So all the tools that I give are meant to help you easily get your project started. So when I pressed the button, when I clicked the link on main Elm, it actually tried to compile my code, saw that it didn't download the dependencies, downloaded the dependencies for me, type checked it, made sure that they had no errors, and eventually showed me the output of my program. So that's nice. No? So yeah, that's a simple example. I probably won't get far within a second one. But Elm also is not only a language, but it's also a framework. And yeah, it was the inspiration for Redux from React. And instead of building an MVC framework, you have a model view updates, and you also have commanded subscriptions for the side effects. So if you want to do some asynchronous stuff, or you want to get some outputs of input from JavaScript, then you can use subscriptions and commands. So the model is basically data struct that you use to compose the state of your application. So what do you have to keep in mind? Messages are all the events that are happening across the system and gets fed to Elm, to a program. Update is the part that manages the state changes. So when somebody clicks a button, the update function gets that message, changes the model, and shoves it to the view, which will eventually show to the user. So this is a simplified explanation of that. We have our model, which is the state. And it's by the view function rendered to the user. Update handles any incoming messages from our user and changes the state based on that. So I wanted to show you another example, but I only have 2 minutes, so I won't go too far into that. I'll show you at the end perhaps a little bit more. So how does it look like in graphics? We have the Elm runtime, which when it gets any messages from the system, go through the update function, change the model, fed it to the view, and update it. So let's say that I have a list of pictures. It will be fed to the view. In this case, it doesn't do anything with those images, but it will generate some HTML, and it will be by the Elm runtime. It will be showed to the user, and it uses the virtual DOM. So that means if something in your HTML changes in between these two cycles, it won't re-render everything, but it will actually check which part of your DOM has changed and only apply those changes to the screen. So that makes it pretty fast. Sometimes you don't only want to change the model, but you also want to do some side effects. So you want to do an HTTP call, you want to get something from JavaScript. In those cases, the update function not only renders a new new model, but also triggers some commands, which will be fed to Elm. The Elm runtime will do something, do some HTTP call, and once it's done, it will give you a new message to the update function, and then the whole cycle goes back in. If you've ever done React, this is probably a very familiar screen to you. So how does interpretability with JavaScript work? Since Elm guarantees no runtime exceptions, interpreting with JavaScript could be a hassle, because JavaScript is not a type-safe language and could result in any kind of errors. So hence the world outside of Elm is kind of scary. And in order to do that, Elm uses ports. So the Elm runtime system will have a port open to some JavaScript function, and it will send out messages to JavaScript, and JavaScript can later on, by that same port, feed messages back to our system. And Elm makes sure that the messages that are coming in from JavaScript are type checked. So if a JavaScript misbehaves and instead of giving out a list of integers gives us a list of strings, then Elm will actually stop that message going through to Elm. So by doing that, it makes sure that our program is still functioning correctly. So this is how we would set up one of these ports. So this one is sending out strings to JavaScript, and this one is getting a list of strings back. So this is how you would set it up. I start a new program, an Elm program from the module spelling, and I run it in full screen mode. And then at the check port, JavaScript subscribes to any incoming messages for JavaScript then. And later on, JavaScript can then do something with those with that input, and then send it back to Elm. So it will, at a suggestion part, it will send it back to the Elm system. So this is how the full code in Elm would look like. These are the types of messages that can get in. I can either change the string, I can run check, which will feed it back to JavaScript, or I can get some suggestions, which are a list of strings from JavaScript back. Hello. And one thing that I didn't show, because I'm short on time, is this is how we would, the example that I showed is just a simple one, which is delivers you static HTML. But if you would run a full-blown program, then this is the way you would start it. Our main function would run a program, HTML program, with some initial model, the view. So these are actually references to actual functions, init, view, update. And these are the subscriptions that I've set up. So the ports in which I get some messages from JavaScript. Some nice tooling. It's really unfortunate that I didn't get to show more code. But Elm has all kinds of nice tooling. So there's an Elm format which formats your code according to a standard. So you don't have to discuss with your team, well, how should we do stuff? Elm format does it for you. There's nowadays also an Elm upgrade. So in between Elm versions, Elm will actually, by using the type system, will actually try to help you upgrade from one Elm version to the next one. Elm Oracle gives you information about the type system. Maybe I can show you later on shortly with Atom. But you can actually inspect, if you have your cursor on a function, which are the input types, which are the output types, etc. And Elm Oracle can then be used in different editors to do that. The Elm package manager is very nice because packages are also type checked. So, for example, imagine that you use some library from a person, and that person decides to make an upgrade to make a bug fix, for example. And the type system will check if that's an actual bug change. So if somebody fixed the code, if somebody added new features, which will then, according to semantic versioning, will be the middle number, or if somebody actually had made a breaking change by changing types. So let's say that you have used a library which has some function and it has a string as an input and has a string as an output. If that person changes the output value or the input value from string to an int, then that would be a breaking change, because if you use that code, then you would get that upgrade into your system. That means your code will break as well. And this is that the package manager will then force that writer of that library to use a specific version. And you can also, by the package manager, you can also request, well, what are the changes between these versions? And Elm will actually tell you, well, these are the functions that have changed. These are the type definitions that have changed. And by doing that, you can actually safely say, well, if I do an upgrade, these are the things that are going to break in my code. Elm also has a debugger. I'll try to show it later on, in which you can inspect all the messages that are coming into your system, and by clicking on them, you can change the state of your application back and forward. So by actually clicking, you can see how your code or how your view looked like at a specific point in time by seeing which messages got in and got out. Semantic versioning I've mentioned. Functional programming is nice because unit testing is a lot easier, and they also have a property testing tool. And there's also a website to try it out. There's even nowadays a live editor, so you don't have to download anything, but you can just go to a website, type some Elm, try it out, and go home. So these are the testing frameworks. I'm going to skip them a little bit. This is one of the examples of how the type system helps you. So once you're typing your code, the type system can already see what you should write. So in the top bottom, you probably cannot read it, but let's say you're writing your update function. You have specified which messages come in. So that's, let's say that those are 3 items. And while you're writing, the editor can already see that you have to write code for those 3 scenarios. If you would forget something or misspell something, the compiler will tell you, oh, you missed something, and that could result in a runtime error, and Elm again saves you from doing that. So this is an example from the package manager in which you can inspect, well, what are the changes between these versions. So in this case, somebody added a function, so it went from 2.0 to 2.1, added a function. If somebody goes and made a major change, going from 2.0 to 3.0, you can actually see that somebody added a function, is empty, but also removed something. Which, if you use this library, you would have a break and change. And this is another example in which somebody figured out they should change the types of their function. Instead of using numbers, they are using floats. So the ports are there to manage the side effects. So that won't result in code that does this. I'm just going to skip this. Since we have 3 minutes left, I'm going to go to the too long, didn't pay attention summary. So if somebody's sleeping, this is the time to wake the person up. So step typing helps us to write, well, not bug-free, but free of runtime errors code. The tooling is good. Compiler errors are very friendly and very helpful. The semantic version is very nice because it's enforced. The type system also helps you to do easier refactoring. So you can safely remove some code because the compiler, or change some names, because the compiler can actually tell you, well, you forgot these places in your code to also change it there. And the mantra is, if it compiles, you can just ship it because it works. And it doesn't have any null values. It does have a notion of nothing, but it's not something that will show up anywhere in your code because, well, it will show up, but you won't get it as a runtime error in your view. And you actually have one thing to learn, only the language. So if, for example, if I would compare it with React and Redux, you have all kinds of things to learn. You have to learn JavaScript, you have to learn JSX, you have to learn Redux. If you, according to best practices, you want to use immutable JS, you want to use some Ramda, which is a functional library to use in JavaScript. You can forget all those things and just learn one language, like I mentioned. And there are also some disadvantages because it's quite a young language. It has fewer libraries, the community is smaller. If you're not used to functional programming, it has a steep learning curve. And there's no official native support in the sense of if you want to use React Native or something else to write native code, there's no official support for that. But being a young community gives you also opportunity to grow your company, to get more familiar, get more known, and it's a really good tool. So with some effort, you also become a better programmer, in my opinion, because you learn more about think more about types. And although there's no official native support, people have written all kinds of stuff with Elm. So there's also support, Thoughtbot wrote Elm native, and also Electron, if it's used to write desktop applications. There's also a library to do that with Elm. And there's also one downside that I forgot. I realized that yesterday. In some companies, people don't ship on Friday because, if it breaks, then somebody has to support it during the weekend. And instead of they go drinking beer early, and with Elm, that's gone, because it's so type safe. You can even ship on Friday. So what is Elm not a good fit for? Things like static pages, short projects. If you want to build quickly an MVP, it's a little bit harder to do because you have to make sure that your code defines all the possible scenarios. It's a little bit harder to do integration with third-party JavaScript because you have to make sure that the ports work correctly. And at the moment, there's no server-side rendering, which is probably coming up in the next version. What is it good for? To write single-page applications, which are quality proven. You can also, if you want to sort out, you can also build some widgets. Some parts of your page can use Elm instead of just using a full-blown application. And you can even write React components doing that. And I think it's also very good for big projects, because the type system helps you build a maintainable software, because the type system can check if you do an upgrade, you don't break anything, and for long-term projects that's really nice. You can come back to your project, change some code, and trust on the compiler to tell you if you broke something or not, which is especially helpful for bigger front-end teams if you even separate things out and write things in different libraries. So this is a summary. It's good for maintainability. The package manager is nice. There's good testing tools. Build tools can be better, but they're there. You can also use Webpack or any other JavaScript tools you're used to. There's good support for editors. Libraries and learning have to catch up. There's a good community, and overall, as a developer, it's something that makes me happy using this. And maybe there are some other advantages which I have got. If you think, well, the type system is nice, you can also use some other languages which enforce this. Bear in mind that the type system in Elm is a lot stronger than other languages, and the compiler will also tell you a lot more than other languages will do. So this is an example from TypeScript, in which instead of having a list of strings, I gave it a list of integers. And TypeScript, where's my mouse? TypeScript will only tell you, well, you didn't supply the correct parameters, but it won't tell you what there actually should be. And the Elm version will actually tell you, well, on this line, on this part of your code, you made an error and you should have given it a string instead of a list of numbers.